Okay, let us look at this question. Okay, we have maximized profit z equals to 70 plus 5c, and then there are two constraints here. The first one is for carpentry constraint, the second one is for painting and varnishing constraint. Okay, let us start with the first constraint. Okay, in order to draw the constraint, okay, first we need to convert to equation. Okay, so the first constraint here is the carpentry constraint. Okay, so just write down the equation 4t plus 3c equals to 240. Okay, next step is okay, we have to substitute t equals to 0 and then find out the value of c. Okay, so if I substitute t equals to 0 here, okay, c will become 80. Okay, this is c. So now just assume the first variable is x, the second variable is y, so the coordinate that we get is 0, 0, 80. Okay, and then okay, we have to find another point. Okay, the simplest form is when you put c equals to 0. Just now t equals to 0, so now we have to put c equals to 0. Okay, and then find out the value of t. So when c is 0, okay, t will be 240 over 4. Okay, right? So t will be equals to 60. Okay, so the second point is 60, 0. Okay, now to draw the axis, okay, we have x and we also have y. Okay, this is x, this is y. Okay, so let us put, okay, let's say this is 20, 40, 60, 80, 20, 40, 60, 80. Okay, now we have 2 points, 0, 80, 0, and then 80 it should be here. Okay, 60, 0 is here, so by using a straight line, okay, just connect these 2 points, okay, with a line. Okay, just make sure that it is a straight line here. Okay, now we have line here. Okay, next is, okay, we have to determine the region that belongs to this constraint. Okay, the constraint is 4t plus 3c less equal than 240, right? Okay, 240. Okay, so now we have to identify which region that represent this constraint, whether it is below this line or is it above the line. Okay, so test at this point 0, 0. Okay, you just test, put t0, c0, so we have 0. Okay, and the right hand side, this is the left hand side. Okay, we have the right hand side. Okay, 0, is it less than 240? Okay, so of course 0 is less than 240. So we test at this point. So the statement is true. So what we can do is we can say that the region belongs to the area below the line. Okay, this is the region. Okay, so settle for the first constraint. Okay, for the second constraint, okay, we have 2t plus 1c. Okay, here it's less equal than 100, but we have to convert, become equation equals 100. Okay, so the same goes to this one. Okay, just substitute t equals 0, 0, and then c equals to 0. Then we get 2 points. Okay, when t 0, okay, c will become 100. So this is the first point. Okay, but when c 0, Okay, just now T0, C is 100. Okay, when C is 0, okay, T will be 50. So we have 2 points here. Okay, so 0, 100. Okay, it should be here, 0, 100. And then 50, 0. Okay, at this point. Okay, so, okay, continue by drawing the lines. Okay, for the second constraint. Okay, say it's here. Okay, now we have to determine the region. Okay, which region that belongs to this second constraint, whether it is above the blue line or below the blue line. Okay, check at the same point, origin 0, 0. Okay, you just substitute. Okay, T0, C0, so we have 0 on the left hand side and 100 on the right hand side. Okay, look at the inequality form. Okay, the inequality is less than, so is it 0 less than 100? Okay, the statement here is true, so we can say that the area for the second constraint is below the blue line. Okay, okay, another constraint here, TC greater than 0. So, okay, TC greater than 0. Okay, this is actually T, this is C. Okay, so the area should be above the axis for X and on the right hand side of the axis for Y. Okay, so now we need to find the redundant region so that, okay, we know where is the feasible region is. Okay, so the redundant region here, okay, is supposed to be, okay, this area. Okay, this is your feasible region. Okay, so we can label this FR, feasible region.